Hi there, folks. Today we're looking at the quadratic formula. And the quadratic formula is our last method for solving quadratics. So far we've learned factoring, which was by far the easiest, but not everything can be factored, so we needed another method. And then we learned completing the square, but completing the square was only easy to do when the a value was 1, when the b value was even. So now we're going to learn the quadratic formula, which just like completing the square will work every time, all right? For some examples, a little more complicated than others. And really, some of you might not have learned completing the square at all, and that's okay. Some of you might not have liked completing the square, and that's okay. You don't ever have to use completing the square again. You can always use the quadratic formula. And many students choose to do it that way. They'll either solve by factoring if it can be factored, or solve by the quadratic formula if it can't, all right? Completing the square is a great in-between method that works well under certain conditions, but the quadratic formula is kind of the go-to for most of us, all right? So what I'm going to do is I'm going to show you where the quadratic formula comes from. And you don't necessarily have to know this, but it's interesting to know. It's important to understand some of those background pieces. You will not have to duplicate this. You do not have to write down what I'm about to do, but I want you to see where it comes from. In fact, I'm about to do this thing in fast forward, so it's going to go quick, but I'm just going to show you the process really, really fast, all right? So what we're going to do is we're going to solve a literal equation. So here it says solved by completing the square. Notice there are no numbers here. It's all variables, all right? We're going to rearrange this equation so that it's solved for x, and that's going to give us our quadratic formula, okay? So here's what that looks like in fast forward. Here we go. So this, ladies and gentlemen, is our quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And it looks like a lot because, again, it's a literal equation. And anytime we've solved literal equations where it was all variables, usually the answer looks a little bit messy, okay? But even though this looks a little bit messy, once you memorize this formula, all you have to do is plug in the coefficients from the quadratic that we're trying to solve, and it will spit out the answer for you, all right? So again, here's the quadratic formula in a print version instead of my sloppy handwriting. But again, the thing to remember here is that quadratics are always in this format. ax squared plus bx plus c. And so when we're looking at this thing, if it equals 0, now the quadratic formula, what it does for me, again, I know it looks like a lot to memorize, but what it does for me is all I have to do is take the numbers from this equation and plug them into this thing, and it spits out the answer for x, all right? And again, this will work every time. So the coefficient right here in front of x squared gets plugged in for a. The coefficient right here in front of the x gets plugged in for b. And then the constant term gets plugged in for c. And again, once I have that memorized, well, this is really easy to do then because I just plug the numbers in. Okay, there's a couple ways that you can try to memorize this. You know, some students will just try to memorize it outright. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Some teachers and some students really like to put this to song, to music. The classic example that teachers use is Pop Goes the Weasel, if you're familiar with that one. But it's x is opposite of the b plus or minus the square root of b squared minus 4ac all over 2a. And so you can put it to that tune, and it makes it really easy to memorize. Or you can go out and find your own. There's lots of versions of this out there. My children's personal favorite is throwing a little Adele at it. So one of these guys. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's the one that they like, but you know, to each their own, whatever you guys want to do. Throw Pop Goes the Weasel at it, throw a little bit of Adele on there, but you have to memorize the quadratic formula, okay? For example, if I take a look at this guy, again, I just have to identify these values. I can see my quadratic formula up here, but here's a, b, and c. A is a 1, b is a -4, c is a -2, and I just plug away, okay? So right now, the b value is a -4, so the opposite of b is a +4. plus or minus the square root of b squared. So again, b was a negative 4 squared minus 4 times a, which is 1, times c, which is a negative 2. And it's really important to have the correct signs there. And keep in mind that first thing in the quadratic form is the opposite of the b value, all right, over the 2 times the a, all right? And again, that's my x values. And now I just plug away. And what you'll see in the end is we have answers that look kind of like we got when we did completing the square, because again, it's technically the same thing, all right? So here, let's simplify. I always simplified in these chunks. I square this thing, and then I do the multiplication this here. That gives me a plus 8 when it's all said and done, over 2. And now the next step, I simplify what's under the square root. And again, that's over 2. And now I have to simplify that square root. Remember, the square root of 24, that is a 4 times a 6. The square root of 4 is a 2. The 6 is still trapped. And now I can use my distributive property to divide each of these pieces. That's a 2 plus or minus. Remember, outside divided by outside here, the square root of 6. And that's it in terms of if I was doing this just as the exact answer here. So if it asks for the exact answer, that's the answer we want, just like we did with the completing the square. If I ask for an estimated value, then you would plug this in and you do the 2 plus root 6 and then separately the 2 minus root 6. And once again, will I ask you for that? Of course I will. All right. For now, we'll just leave it like this. Okay. But practice plugging that into the calculator. It's 2 different things. Okay. Same thing with the next guy. The problem with the next one is this is not in the right format. If we come back up here and see what I drew in green, notice it's ax squared plus bx plus c equals 0. And so just like when we were trying to use the zero factor property, this has to be equal to 0. So I have to subtract this guy first, and I have to put it in that format. Ax squared plus bx plus c equals 0. Now I can see my a value is a 1, my b value is a negative 2, and my c value is a negative 5. All right, now I can use my quadratic formula. The opposite of b is a positive 2, plus or minus the square root b squared, so that's a negative 2 squared, minus 4 times a, which is 1, times c, which is a negative 5. And it's all over 2a. Which, of course, again, is a 1. And I would just start simplifying this in chunks. So I have 2 plus or minus the square root. Looks like a 4 and then a plus 20. So I happen to have a 24 under the square root again. Geez, get some fresh examples here, Mr. Jansen. Ridiculous. No, it won't always be a 24 under there. This is a coincidence. All right. But again, this reduces, so we're just simplifying the radical. And if we want to keep this thing in radical form, if we want to have the exact answer, I have to simplify the radical. And now I use my distributive property. 2 divided by 2 is a 1, plus or minus. And then the outside numbers, 2 divided by 2 is also a 1. So I'm just left with the square root of 6. Okay? And that's it. All right? Again, if I asked you to estimate, you'd have to plug that into your calculator twice. Once with the plus, once with the minus. All right? If I look at this guy, same kind of thing. I can see A, B, and C. It's equal to 0, so it's in that proper format. So now I go right to the quadratic formula. X equals the opposite of B. See, this time, A is a 1, B is a positive 3, and C is a positive 8. All right, so the opposite of B would be a negative 3. B squared, so 3 squared minus 4 times A, which is 1, times C, which is an 8. All over 2 times 1. And now I just start simplifying, okay? So here I've got negative 3 plus or minus the square root. Looks like a 9 minus 32. And just be careful with your signs here. That's where students usually make mistakes, is underneath that square root when they're dealing with that negative 4 times the other stuff, okay? But now when I subtract these, it looks like I get a negative 23 here. And once again, for our purposes, can we take the square root of a negative? The answer is no. When you get to Algebra 2, you'll actually find imaginary solutions for this one. But for our purposes in Algebra 1, we're going to say this is no solution. Okay? Really, it's no real solution. All right? If I look at the next one, again, it's not in the right format. I have to subtract the 6x from each side. And now it's in the proper format, 3x squared minus 6x. And notice it's descending order. You have to have this thing in descending order. It doesn't work. Now I can see my a, b, and my c. Okay, the a is a 3, the b is a negative 6, and the c is a 2. All right, so the opposite of b would be a positive 6. B squared minus 4 times a, which is 3, times c, which is 2, all over 2 times a, which is a 3. Now again, I simplify, and I start the same place every time. Consistency makes this a lot easier. I always square this guy so that it's a 36, and then I do the multiplication. Negative 4 times 3 times 2 gives me a negative 24, or a minus 24 there. And now I can continue simplifying. Now I take the what's under the square root and I do the subtraction, or if it's addition down there, I would do that. So that's a 12. And now I simplify the square root of 12. The square root of 12 is, so it's 4 times 3. The square root of 4 is a 2. The 3 is still trapped. And again, if you need to take that off to the side, by all means, please continue to do that, all right? Now I can divide this up. So I do 6 divided by 6 is a 1, plus or minus. 2 divided by 6 is a 1/3, so I'm going to leave it as a fraction. So it's 1 root 3 over 3, okay? And that's how I kind of write that, all right? But I'm still doing my distributive property, 6 divided by 6, and then the 2 divided by 6. That's where I get that 1/3. And you don't have to write the 1 that's there, all right? But again, if I wanted an estimate there, I would have to plug 2 things into my calculator. So please be aware of that. You may have to plug some of these into your calculator, just like we did with the other ones, okay? This one, once again, is not in the right format. I got to subtract that 6. See, I need it equal to 0 for it to be in that format of ax squared plus bx plus c equals 0. And now I can see it. A is a 2, B is a negative 5, C is a negative 6. Be aware of the signs, all right? So the opposite of B is a positive 5, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A, all right? And now I simplify. So let's see, that's 5 plus or minus the square root. Same couple steps every time. Negative 5 squared is a 25. Now I deal with that multiplication. Negative 4 times 2 times negative 6. See the 2 negatives in there? That gives me a plus, okay? A plus 48. All over 4. And now I continue to simplify. I add up the 25 and the 48, and that looks like that gives me a 73. Well, there are no perfect squares that divide evenly into 73, so I can just stop there. You don't even need to bother doing the distributive property, all right, because nothing's simplified, so I can just leave it as a big ugly fraction like this, okay? And again, if I wanted an estimate, I would do 5 plus the square root of 73, and then 5 minus the square root of 73, and then divide each of those things by 4, okay? But make sure you understand how to plug that into the calculator. You'll get some practice with that a little bit later, okay? This one, it's in the right format, so I can go right to opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So the opposite of b this time is a negative 7 plus or minus the square root of b squared minus 4 times a times c, all over 2 times a, which is the 1. All right? And again, it's all about just memorizing this formula, and then we can plug in the pieces. Negative 7 plus or minus the square root looks like a 49, and then a plus 4 when it's all said and done because the negative and the negative. All right, so again, be careful with those signs. And now I continue to simplify. That's a negative 7 plus or minus the square root of 53 over 2. And once again, there is nothing I can do about this one. I have to kind of just leave it the way it is because I can't simplify the square root of 53. All right, so I'm just going to leave it this way. This is my answer. All right. So again, make sure you go through and memorize the quadratic formula. That's the most important thing you can do from this lesson. Once you have that memorized, it's a matter of just plugging the values in and doing order of operations to simplify. All right.